welcome to Greenslade Company. Today we're going to be demonstrating hydrogen embrittlement testing on some M5 by 0.8 trilobular tapping screws. We're going to be doing this demonstration using our STF-250, our screw test fixture. But first we want to gather all of the tools and equipment we're going to need to perform this test. We're going to need some washers, preferably hardened steel. We're going to want to use our ratcheting mechanism for our torque wrench, maybe some adapters as we might need to adapt our torque wrench to our fixture. We're also going to need our driving bit, our T25 6-lobe. We've got a selection of torque wrenches here because at this point we're not sure where our braking torque is. We've got our test plate holder. We've also got our tapped and hardened test plate. And lastly, we've got a couple clamps so that we can make sure that we've got our fixture secured. So let us begin. First thing we want to do is we're going to need to secure our fixture to the workbench or work table. Now there are 4 holes in the corners. If you are out in a shop and you have that ability to be able to fasten it right to the bench top, you can drill holes in your bench and fasten it right there. You don't need the clamps. I don't want to drill holes in my table, so we're just going to use clamps today. We're going to grab our test plate. We're going to grab a washer. We're also going to grab our test screw, and we're going to screw them into the test plate. Now what we're going to do is right now we're going to populate 5 holes with screws to determine the braking torque. Okay, we now have our 5 fasteners in place. We're going to install our test plate holder with our test plate. We've got our driver bit, our T25 driver bit with an adapter. We've got our ratcheting mechanism. We're going to start out with the smaller of the torque wrenches. But first we're going to have to course adjust. Let's bring this up a little bit. We're going to course adjust our upper arm down to about where we're going to need it. Lock that into position. I'm going to come over and hover over the top of our first fastener. What you want to do is make sure that this is seated properly. You don't have to use a lot of hand force, brute strength. You just want to have finger force. It's nice and tight. What that does is ensures that that bit is going to stay in the recess and not hop out while you're performing your test. So we click our torque wrench into place. We want to set our memory needle if you're using a dial. And we're going to begin to turn. And as we go, we might have to readjust our hand wheel just a little bit. I'm up to 20 inch-pounds at this point, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. Oh, we've reached the maximum of our torque wrench of this size, so we chose unwisely for our first wrench. We're going to jump to our larger wrench since we've maxed out that one. Again, make sure we're at 0. And right now we are up to 80, 90, 100, 110, 15, 20, 25. Looks like we have broken at 125 inch-pounds. What we're going to want to do is record that value. And we're going to continue to do that exact same thing for the remaining 4 samples. Now that we've broken all 5 of our fasteners, we're going to do some math to determine what our testing torque is going to be. Our samples broke at 125 inch-pounds, 100 inch-pounds, 110 inch-pounds, 110 inch-pounds, and 110 inch-pounds. We calculated an average at 111 inch-pounds. Then we multiplied that by 0.8, which represents 80% of the yield, at 88.8 inch-pounds. Rounded that all off to 90 inch-pounds, which is our final testing torque. Alright, since we've determined our testing torque to be 90 inch-pounds, we've gone ahead and we've repopulated our plate, removing the broken ones and replacing them every hole with a fresh fastener and washer. Basically, we're using washers underneath the head. What that does is helps take up any of the thread washout that's under the head. You may need to use spacers, you may need to use more than one washer. It just depends on how much of the unthreaded length we're dealing with. And it's a case-by-case scenario. So first thing is we'll pick a spot to start with on our plate, and we want to make sure that bring the hand wheel down so we're locked in nice and tight, and we're going to bring this up slow and methodical to our 90 inch-pounds. What you want to do is you want to bring it up slow, and when you get there you're going to kind of just hold it till your torque wrench really stops moving. Once you're there, you've basically tightened to the 90. You're going to back it out, and you're going to just go to the next one. You just want to come up with a pattern so that you make sure that you've actually hit every fastener in the plate and didn't skip any by accident. So you do this entire plate like that, and then you're going to want to set it aside for 24 hours and come back and repeat this test. Okay, here we are 24 hours later. We have our test plate that we've pulled back off the shelf. First thing we want to do is a visual to see if any heads are missing. If a head is popped off in the past 24 hours, that means we have a failure. And we still continue our test, but that means that we've confirmed a failure. Now, we don't see any heads popped off here, so we are going to perform our test. And all we're going to do is we're going to, again, start in a position. We're going to bring our bit into our recess nice and snugly. We're going to re-zero our torque wrench, and we're going to start to torque. And we should bring it right up to 90 and hold it. And if anything does break during this portion of retightening, that means that we do have a confirmed hydrogen embrittlement failure. Now, what will end up happening is that it will break well before you reach your 90 inch-pounds, because typically what happens is it's already broken and you are just giving it that last bit of torque necessary to finally let it loose. But yeah, you methodically go through the rest of the samples in your plate and make sure that they're all still at 90. There'll be a little bit of creep that has come in through the night, and you'll have to just a quarter turn or something like that that'll get you back to your 90 and continue on the test. Again, any failures at this point are hydrogen embrittlement failures. Okay, here we are again, 48 hours later. We grab our test plate again, we place it into our position, and we perform our tightening process once again. Again, methodically go through them all. If you didn't have any heads that were broken or heads that break as you're doing this, you have a successful test. When you're done doing that, once again, you want to just set it aside. We'll do this as a 72-hour test just to make sure. Okay, here we are 72 hours later. We're going to once again position our test plate in our fixture with our torque wrench, settle our bit into our recess, and perform another tightening. Again, when we go through this tightening sequence, if anything does break, we do have a hydrogen embrittlement failure. If anything has broken between the time we installed and up to this point without us doing this tightening test, then it is a failure. If we've gone through all 72 hours with no breaking, then we can confirm that the lot we tested does not have any signs of hydrogen embrittlement failure and can be used to populate other assemblies as needed. Thank you very much for joining us as we went through our hydrogen embrittlement testing procedure. Make sure to come back and visit our website because we have many other links to other testing procedures that we would like to share with you. Also, anytime you want, you can always contact myself, Larry Borowski, or any of our other sales staff here at Greenslade & Company with any questions pertaining to any of the equipment we sell or manufacture. And keep in mind that we sell and manufacture equipment if you've got a fastener that needs testing or measuring, we make equipment to do it.